Hi, my name is Jeff Mieleff, and I'm a Principal Program Manager with the Office 365 team. And today I'm here to talk about the internals of Exchange Online and what we do behind the scenes to make sure that Exchange Online is a highly available, great experience for all of our customers. So let's start off by talking a little bit about the scale of Exchange Online. And it's really quite amazing to look through some of these numbers, given that Exchange Online actually started out as a single server under someone's desk in our corporate headquarters in Redmond, Washington. Today we actually have over 150,000 physical servers spread out across 35 data centers, 16 countries, and over 70 network points of presence around the world. Keep in mind, we're also talking about Office 365, the commercial service, Exchange Online, plus Outlook.com, formerly known as Hotmail. We actually share quite a bit of infrastructure between the two in order to take advantage of this scale of hardware and our global spread. From a storage perspective, we actually have 670 petabytes of logical data on disk. And when you think about the fact that we actually store 4 copies of all of our user data in order to survive any sort of issues that we might have in our data centers, either physical issues with the data center facility or servers having failures, etc., multiply that 670 petabytes by 4, and then we're actually talking about the amount of storage that we use across all of these servers on a daily basis. That consists of 20 trillion items at the point that we measured this a few months ago. And we're actually adding 5.5 or almost 6 petabytes of data a day. So this is constantly growing as we onboard new users into the service and as our existing users take more and more advantage of the services that we provide. We process 6.5 billion messages through the service on a daily basis. Right? The primary thing that an email system does, obviously, is send and receive messages. So 6.5 billion of those a day. We're blocking 2 billion of those spam messages on a daily basis. We've got 225 billion requests coming into the system. So those are clients performing some sort of activity against the system. And we're actually opening or reading 1.2 trillion items on a daily basis. Pretty massive numbers, and it's quite impressive that we're able to do this with the availability that we have. So I mentioned that we have a very large number of data centers and quite a global spread. So this diagram actually shows both the Exchange Online data centers, the physical data centers where we store user data and where we process user data, as well as what we refer to as service front doors, which are those network point of presence locations where we have some infrastructure that will take client requests and proxy them to the appropriate location. So within this Exchange Online data center footprint, we have a number of Go Local regions that are smaller regions outside of the original sort of large North America, EMEA, South America regions that we launched with. And those would include Canada, the UK, India, Japan, Australia, France, and South Korea. We've also announced some others and continue to grow those Go Local regions that we have presence in. We also have 2 sovereign locations, China and Germany, where we actually have separate instances of Office 365 specific to those locations that are managed in slightly different ways or deployed in slightly different ways to comply with local requirements around data sovereignty. We like to point out that Exchange Online runs on intelligence. And what we mean by that is that we're constantly monitoring the system and learning from how the system is utilized, how users are connecting to the service, how the service is responding to requests. And we also learn from the content that exists in the service. So we constantly are finding new ways to actually use the content that makes up user mailboxes in order to provide new compelling features that make our users more productive. We'll spend a bit of time at the front here talking about service intelligence and how we build the service to, in many ways, be self-monitoring, self-healing, and allow us to operate at the scale that we do. And then we'll talk a little bit about how we utilize that data in that actual user data to provide those new features. So we'll start off with a little bit of information about data and monitoring and how we use the data that reflects how the system and the infrastructure is being used in order to respond to issues that occur in the service and provide great availability. So the top of this slide actually shows Office 365 availability numbers all up. So this is Exchange Online plus all the other components of Office 365. You can see that in general we're looking at 4 nines, 99.99% as sort of that upper bound of the numbers that we show there. In reality, Exchange Online actually runs at much higher uptime than that. So the bottom chart has 99.95, so 395 is the sort of the middle line through the line graph there. And as you can see, we're actually very close to 100% in many of those months. We actually run at close to 5 nines on an ongoing basis within Exchange Online. So Exchange Online availability actually is sort of the, setting the high bar for Office 365, which is a fantastic thing. So how does this work? How are we actually able to provide that level of availability? Well, you could think of this as sort of a pipeline of data coming into the service, data from multiple sources about how the system's operating, how it's being used, how it's responding to requests, and then how we take advantage of that data to perform actions that keep the service operating in an optimal way. So we start off with client and server code being instrumented. What we mean by that is that there's, within the software code that actually makes up the Exchange Online service, we have additional code beyond just the features and functionality that are part of the product, which, the sole purpose of that instrumentation code is to collect additional data, log that data in a way where we can get to it in an effective way, and then correlate that data in interesting ways. So we start off with client and server code being instrumented. And of course, by client, we mean that all the clients that are talking to Exchange Online are also pushing this instrumentation data up. So your Outlook client, your OA client, other clients that talk to Exchange Online, they're also pushing data to us on an ongoing basis as part of this pipeline. So we collect these signals that we call them think of it as a very large data warehouse, and then we process these signals. And we take signals from all portions of the system, whether it's client, backend infrastructure, different components in the service that describe how the system is operating, and we use those different signals as inputs to make decisions. So we perform multi-signal analysis. Again, if we're receiving signals that are aligned from multiple sources, we can use that as an indicator that the implication of those signals is likely going to be much more reliable compared to, say, a single signal coming in suggesting a particular action needs to be taken. So that multi-signal analysis, getting that information from multiple sources, is a very key thing for us to be able to make the right decisions and perform the right actions within the service. If we discover that there's something wrong that we need to respond to, we have automation that can take recovery actions without actually, in many cases, having to involve actual humans getting involved in the process. We have a process that runs in the service called Rescue Box that can do things like take servers out of rotation, take entire racks and put them in, fail them out so they're not responding to service requests, manage network changes behind the scenes, throttle services, take performance traces so that developers can investigate potential problems and resolve them without actually having to get onto the machine and take those traces manually. We also have visualization that shows us in real time what's happening in the system, how users are interacting with the system, and what sort of experience that they're having. So as we potentially need to get engaged and troubleshoot issues, we can get this real-time visualization to help inform and make decisions. So a good example of this is a gray failure auto recovery that we experienced recently. So what you're seeing in this slide is an overview network diagram of connectivity between a few different locations where we have Microsoft facilities: Helsinki, Stockholm, Copenhagen, Amsterdam, and Frankfurt. And in this particular case, you can see that we have, so each line between these locations represents a network link. And you could think of the width of the line as being an indicator of the bandwidth available between those sites over that link. So you'll see that in many of these cases, or in between many of these sites, there's multiple links with varying levels of bandwidth. In Europe, we generally design our network connections to be able to support single-site failure because we have very highly reliable communications within Europe. In other parts of the world where we have less reliable communications, we actually design our networks a little bit differently to be able to support additional failures. But in this case, we're designed to be able to support single failure. So unfortunately, the issue that we ran into here were multiple fiber cuts between the Helsinki and Amsterdam locations. In the case of Helsinki and Amsterdam, we actually have mailboxes being served out of both of those locations. We actually have Microsoft Exchange Online data center locations in those facilities hosting mailboxes. And these multiple fiber cuts leave us with a single path between Helsinki and Amsterdam. And unfortunately, the high bandwidth paths are the ones that took the hit. So we do still have connectivity. However, we've actually lost a significant amount of bandwidth between those locations. So what happened? Well, the first thing that we notice is that network availability drops for the Helsinki location, and our network resource health, which is a measure that we use of health across all the components within the system, goes critical. Shows up as red or black on that diagram. In response to that, we actually start to drop what we refer to as scavenged traffic. So we'll actually tag some of the traffic that we use for things like lag copy replication as traffic that you can think of as sort of nice to have. Not absolutely necessary to keep the system up and running, and certainly end users will not notice if we stop lag copy replication. They would notice if we stopped servicing OA requests or if we stopped servicing Outlook requests. But lag copy replication is something that happens totally behind the scenes. We can turn that off for a period of time if we need to. In this case, we did, and that significantly reduced the bandwidth consumption between Helsinki and Amsterdam. We also start to see discretionary loads back off. So we actually label certain types of compute that's happening in the background as discretionary load. So there's certain processing that happens as changes are happening within user mailboxes. In order to provide some of these advanced features that exist in Exchange Online, we can begin to turn some of that off, and also, as a result, reduce some of the churn in our data, which results in a reduction in the amount of replication traffic that we have. So when we start turning those discretionary loads down or throttling them, as they back off, the amount of data transfer also begins to dramatically reduce. So far, what we're talking about here, no humans were involved in actually making any of these changes. The system is responding to these events that are occurring based on the signals that are coming in through this process, through that instrumentation that I described earlier. So as we kind of move through this timeline, we continue to notice that we need to perform additional response actions in order to get the system healthy again. So the next thing that we do is we actually activate database copies in other locations. So as a result of this, we actually switch out 70 racks worth of servers so that we no longer have active database copies on those racks in Helsinki. At that point, the system becomes much healthier from a network perspective. Users are able to access their mailboxes in a completely healthy way. No one's really noticing the problem at this point from a user perspective. We're certainly still aware of the problem, monitoring things and making sure that the right things are happening. But again, all of these actions that have been performed, fully automated, and no engineers actually had to get involved to resolve this. Over time, those fiber cuts get resolved, network availability goes back to healthy, and the system responds to that as well, right? We're able to receive signals from the system, understand that we've got our bandwidth back, and we can begin ramping up some of that discretionary load and that lag copy replication that we'd halted. Additionally, with all of these signals that come in, we have a massive amount of data about how the system works, how we're responding to alerts and events in the system, and we review those on an ongoing basis to understand whether or not we're doing the right things with monitoring and with responses to the monitoring that we have in place. This is an example of some analysis that we ran to better understand why we were seeing so many escalations. You can think of escalations as the number of times that an engineer is getting involved in an issue that's occurring in the service. So using all of these signals, all of this data that we have available to us, we can go in and at a very granular level understand exactly what's causing these escalations, which components of those increases we need to care about, and how we can start to address these so that engineers are actually only really seeing the escalations that they need to care about, and the system is doing the right thing behind the scenes to actually respond to those problems that we can respond to in an automated way. In this particular case, we actually found that the bulk of the escalations, the new escalations, or the bulk of the increase in escalations was coming from some new monitoring code that was checked in, that was added to the product on the back end, that was actually causing large numbers of escalations to be fired that were not actionable. So this was a simple case of turning off essentially some useless new monitoring code that wasn't providing good actionable signals to our engineers. This is an example of something that we do on a very ongoing basis to ensure that we're always getting better and better at responding to issues that occur. So we have very, very deep experience in this. We've been doing this since the beginning of Exchange Online, trying to build our muscle around building this pipeline of signals coming in and analyzing those signals to do the right things to keep the system up and running and healthy. Overall, we want to make sure that every single customer is actually having a great experience with the product on an ongoing basis. And the only way that we can do that at scale, when you think about how many mailboxes, how many users, how many customers we have that rely on Exchange Online every day, the only way that we can do that is in an automated way, like I've described here. So we really hope that we're going to delight everyone across the board with the availability and the performance that you get out of Exchange Online. Additionally, we talk a little bit about speed of light here. What we're describing is some work that we've done around better understanding how our users access the service in order to provide them with a better quality of service as they connect into Exchange Online. And that takes up two components, or consists of two components. A slightly different routing architecture from what we've had historically for routing those inbound requests, and also some innovation around how we store mailboxes and how we move mailboxes around to better optimize connectivity. So from a routing architecture perspective, we try and take the shortest path possible between end users and Microsoft's global network. Microsoft has a huge investment in our network technology around the world. The Microsoft Global Network, we refer to it as AS8075. That's the autonomous system number that we are known as on the internet. If you're a networking expert or an internet service provider, you'll be aware of AS8075. It's one of the top three. I believe we're calling it one of the top two networks in the world in terms of the breadth of coverage and the amount of bandwidth that we have deployed globally. We actually have presence from a networking perspective in over 150 public peering locations where we have connectivity with internet service providers around the world. And that's really designed to take that traffic from our end users and get it off the public internet as quickly as possible and onto Microsoft's network, where we can control that end user experience and ensure that you're having the highest possible performance with our products. From an Exchange Online perspective, once we get that traffic onto our network, we want to make sure that you get to a service front door. In other words, that initial connection point where a client connects into the service. We want to get you to that service front door as quickly as possible to minimize the latency of all these requests that you're making to the service. And we do that in a couple of different ways. So we have a GeoDNS implementation of this service, where we'll detect where you are based on a GeoDNS signal and point you to a service front door that's appropriate for your location. But we're actually moving to what we refer to as Anycast DNS on Cafe, ACDC. This is a new innovation that we've deployed fairly recently that we're serving about half the requests that come into Exchange Online with today, where when you resolve the endpoint name for Exchange Online to make that connection into the service, the DNS servers that actually will be used to respond to that request are advertised via Anycast. Anycast means that there's a single IP that's associated with multiple endpoints on the internet. And using internet routing infrastructure will get you to the closest location servicing that IP endpoint that we can. So in practice, the way this works is your client makes a DNS request for something like outlook.office365.com. You get pointed to the closest DNS server that can resolve that, and that's actually going to be that cafe server, that client access front end or service front door server, that will then respond with a set of IP addresses that are appropriate for that region. The client will then connect to the best possible cafe server for that location and make the request appropriately. We provide multiple endpoints so that if one of them is not available, that the client will then fail over to one that is. So we provide an always available service with the lowest possible latency as a result. From an application request routing perspective, the other thing that we're doing here is ensuring that we're providing the shortest possible path between the service front door and the data center where the active copy of the user's mailbox is. And with this routing process where we actually make multiple hops between cafe servers, we've been able to reduce latency quite a bit. Another thing that we're doing in this space is actually trying to optimize where mailboxes are located. Now, the primary thing that matters from a latency perspective is actually ensuring that the connection between the client and that service front door, cafe server in the case of Outlook connections, or the Azure front door in the case of OA connections, that initial connection into the service, we want to have that latency be as low as possible. So getting you to a service front door that's close to where you are geographically is really the most important thing. But when we kind of peel back the onion a little bit and look at the next layer, the next thing that we can do to really influence latency or influence the perceived performance of the service is how close you are to your data. So within a given region, again today, we keep mailboxes within the region where your tenant is located. Within a given region, the active copy of a mailbox could be anywhere within that region. So if we think about North America, a user could be coming from, say, San Diego in Southern California. The active copy of their mailbox might be in one of our data centers in Virginia. So fairly long distance between those. And we may be able to connect to a service front door in the Bay Area, fairly close, or even maybe LA, fairly close to the user physically. But that next hop back to where the data actually exists, that's a fairly long distance all the way across the US. Well, given that we know where these connections are coming from, and we collect that as one of the signals coming into the service, we can actually optimize mailbox location, or in general, the preferred location of the active copy of a mailbox based on those signals. And so what we've done is taken that information and use that as an additional signal in the process that we use to balance mailboxes across the service. We've always needed to balance mailboxes across the service for performance, for space utilization on the servers, but now we're looking at where that user is coming in and making requests from in order to try and minimize that latency as much as possible. So this isn't really something that you have visibility into or control over, but it is something that we're doing behind the scenes to try and provide the very best possible experience with the service. So we've got a quick announcement here. You may have heard a little bit about this already, but we'll go through some information in more detail here. We are announcing a multi-geo capability for Office 365. It impacts both Exchange Online, OneDrive for Business, and SharePoint Online. We'll talk to the Exchange Online implications here. You could think of this as opening up or unlocking the ability to have an Office 365 tenant in multiple regions. So rather than having to, for a multinational company, pick the most appropriate region and have all of the Exchange Online data contained in that region, and then have to kind of figure out the most optimal way to get your users in other parts of the world to that tenant, you can now relocate portions of your tenant into different Office 365 regions as your business needs require. So what does this look like? The way you might have dealt with this in the past would be to have a tenant in, as an example here in North America. We've got Contoso.com as the organization. Contoso has some users in Europe, and they also have some users in Australia. So we've got 20,000 users in North America, 5K in Europe, and 5K in Australia. And this particular organization has chosen to leave on-premises Exchange deployed in Europe and Australia in order to provide good performance to their end users. It's a perfectly legitimate way to do that. It can be hard to manage that bandwidth and latency requirement to get those users in those remote regions into the North America tenant in an effective way. So with the multi-geo capability that we're announcing, you can now establish European capacity within that Contoso.com Exchange Online tenant. It just becomes a seamless portion of your existing tenant where you can associate particular mailboxes with the European capacity and have those mailboxes migrated into that location in order to provide the best possible service to those users. So we'll migrate those users there and get them off of the on-prem deployment. And then we can do the exact same thing with some additional Australian capacity. We'll get rid of that on-prem deployment, migrate those mailboxes into Exchange Online, and now we have this single tenant in multiple regions providing a great service around the world. Once we're already in the cloud, we can also then establish additional regions within the tenant. So hypothetically, we open a new office in Japan. We're going to have some of these users that already exist in one of the other regions, physically relocate to Japan to open this new office. Well, we can then move their mailboxes into the Japan capacity and have that just be part of that same Contoso.com tenant. So again, it's one tenant, same SMTP namespace, so it operates as a single organization, one GAL, global address list. Everything operates as you would expect a single tenant to operate, kind of in the same way that you might have had an on-premises deployment that spanned multiple regions globally. Important to call out here, if you are a multinational company and you have an internal wide area network where you have a small number, perhaps one point of egress to the internet, this is really a bad design with Exchange Online. I've mentioned that we do a lot of work to try and get your connectivity into one of those service front doors as quickly as possible based on where your users are physically located. And we also have this new capability with Exchange Multi-Geo, Exchange Online Multi-Geo. Having these single points of egress means that you're actually backhauling traffic across your wide area network to one of these locations, getting it out onto the internet and getting it into Microsoft's network. And you're not actually able to take advantage of the global reach of these service front doors. And you're also not able to take advantage of the potential latency improvements that come from having a multi-geo deployment with mailboxes deployed in multiple physical regions. So we absolutely prefer a model like what's shown in this slide, where you have egress points that are either regionally centralized, so you could still have a corporate wide area network that takes traffic from some of your smaller branch offices into regional egress points, or even better, actually have that traffic going out onto the internet directly from each one of your branch offices, if at all possible. That's the optimal case for Exchange Online and really for Office 365 in general. So keep in mind, single points of egress bad. Ideally, you want to have each one of your offices or regions, if that's not possible, egressing onto the internet. So when we release Multi-Geo, and it's in preview today for Exchange Online and OneDrive for Business, in development for SharePoint Online, it will launch in the listed global geographies. We expect France to come later. It won't be initially available at launch. And you can certainly work with your Microsoft account team to understand whether or not it's feasible to get into the preview or what the specific time frame is for this becoming generally available. If your account team is interested in actually nominating you for the preview or getting more information, there's a link on screen, aka.ms/MG customer nomination, that your account team can use internally to get you engaged with that process. So the tentative general availability is first quarter of calendar year 2018. One additional announcement we're talking about is what we refer to as MetaCacheDB, Metacache database. Metacache database is an innovation that we've done from a storage perspective in Exchange Online to try and reduce the latency of common transactions coming into the service. You could think about this as sort of storage tiering, but very application-aware storage tiering. So unlike traditional storage tiering architectures where you have some sort of a storage solution that looks for blocks of data that are being accessed frequently and moving those into faster storage behind the scenes, this is actually taking an additional sort of cache copy of portions of the Exchange database, things like message table data, user information that's used for the login process, aspects of the search indexes that we use for quickly searching through mailboxes, taking that information and creating a cache copy of it on SSD, we're actually able to very dramatically reduce the latency of some of these common transactions. Again, we're not actually relocating data onto faster storage. We're taking advantage of the fact that we have some faster storage available and keeping an optional optimized copy of it on that fast storage with the slower traditional hard drive storage being used as the additional source of truth, shall we say, so that if the SSD goes away, we're still able to operate normally. So it's not exactly the same as what you might be familiar with from a storage tiering perspective with traditional implementations of it. It's much more specific to the demands of Exchange, and it's designed with the requirements of Exchange, entirely end to end. So let's talk a little bit about how we utilize some of these signals that exist in user data to provide interesting new scenarios and interesting new features in our products. Some examples of this would be things you may be familiar with if you're on Exchange Online today, or things you may have seen in some of our marketing materials or demos that we show. For example, on a Windows 10 machine with Cortana, Cortana will actually become aware, based on the content that's flowing through your Exchange Online mailbox, of commitments that you make. And this is contextual information about statements that you make to your coworkers, like I'll respond to you by end of day with this presentation. Cortana actually becomes aware of that based on signals that are produced in the Exchange Online backend as that content flows through the system. Flows through Exchange Online, flows into a pipeline where Cortana can become aware of it and provide those reminders and that great contextual help to make sure that you're following up on the commitments that you make. Additionally, within some of the clients that access Exchange Online and your Exchange mailboxes, we provide what we call actionable cards. So we're detecting certain types of content. An example that we show on screen here is the example of an airline reservation where you're taking a trip to a particular location. We can extract the information about the flight details, show you some detail about that provides some additional productivity without actually having to scroll through the entire reservation details. You can quickly at a glance see the things that really matter to you about that flight, when it's departing, when it's going to arrive, a check-in link in order to get checked into that flight. So we're trying to detect cases where there's information that can be extracted and displayed in a better way to make you more productive. And we can also in this Dynamics Relationship Assistant example, show you where we're extracting text from emails and providing details on upcoming activities that you have scheduled. So where does the technology come from that we're actually using to create these features? It's really coming from a collaboration between Bing and Office 365, where we're taking technology that the Bing team has developed in order to produce the features that make up the Bing search engine and the other components that Bing provides. So they certainly understand how to very effectively index and search data. They certainly have great technology for taking published information and trying to distill it down into knowledge that you can act on. And they have great technology for natural language processing, understanding the context and the meaning of statements that exist in written form. And they also have excellent technology for understanding what people are saying verbally. So taking speech and performing action based on speech. On the Office 365 side, we have a lot of data, a lot of information where we can apply some of those technologies. So the conversations, events, contacts, and documents that exist in the Office 365 service, with much of that data existing in Exchange Online, when we bring those two areas of technology together, that's where we get some of these rich experiences and new features. A great example of this is actually taking some of the search technology that makes up the Bing search engine and replacing the legacy search engine in Exchange with that Bing functionality. We're referring to this internally as Big Funnel. I guess since we're talking about it at many of our events, it's not really our internal name anymore either. But Big Funnel refers to taking those search components that matter out of the Bing search engine, the indexing components, and the search components, and actually integrating those very deeply into Exchange. So what we end up with is a very fast and very compliant per mailbox index of information. So unlike the legacy search engines that we've used for Exchange in the past, where you index an entire database consisting of many mailboxes, and you have that database, that index external to the database and have to kind of manage it separately from a storage perspective, we now have each mailbox being indexed individually with the storage of that index actually contained within the mailbox. So no longer do we have the separate index that we have to replicate and manage on its own. We now replicate the content index with our database availability group technology. From an end user perspective, being able to quickly search and quickly populate these search results means we can do things like smart captions, advanced ranking, top results, some of these things that you would expect out of an internet search engine that we haven't really had within the experience of Exchange in the past. We can now kind of merge those technologies and provide a great, compelling end user experience. Really important to call out as we talk about how we're using content in the mailbox to actually provide these experiences, that we're not actually monitoring the content in these mailboxes to build these experiences. What we're doing is building technology that can utilize the content in these mailboxes and understand on its own how to learn how users are interacting with content, how they're communicating with other users, and build these models that are specific to individual users in a fully compliant and trustworthy way. That's very much aligned with all the commitments that we make within Office 365 around control over your data, transparency of how we utilize your data, your ability to verify how we're maintaining your data, et cetera. So really important to understand that everything that we're talking about is completely aligned with all of the commitments that we make in this space, and we do not have access to this customer content. It's software that's running and kind of growing and learning from the ways users interact with their data and communicate with others. That's making this possible. And there's more. So as part of being within the Office 365 suite, Exchange Online actually supports a single API or extensibility endpoint that we refer to as the Office 365 graph. The Office 365 graph is a set of API endpoints that provide access to things like users, groups, messaging data, calendaring data, information that's stored in OneNote, Teams, Planner, etc., where line of business application developers or third-party application developers can target this set of API endpoints and actually access Office 365 as a complete suite of services rather than building something that's specific to Exchange or a specific version of Exchange. You now have access with one endpoint, one token, and all the users across Office 365 to be able to get to all these services and build really compelling applications and solutions. Important to call out here that we're actually providing some of this intelligence that we've described to our on-premises users as well. And the example that we have here of this is how we're providing Outlook mobile access to on-premises servers. The way we're doing this is actually synchronizing on-premises mailbox data into Office 365 mailboxes. The Outlook mobile client is really designed to access Office 365 mailboxes using an Outlook device API that really understands how to communicate with Exchange Online. It doesn't use, it's not designed to use Exchange ActiveSync to communicate with an on-premises Exchange server. So what we do is actually synchronize data from the Exchange on-premises server into Exchange Online mailboxes that are not, traditional Exchange Online mailboxes that you would log into with OR or Outlook. They're only used as this data, sort of behind-the-scenes data cache. So we synchronize the mail into Exchange Online, and then we could take advantage of the existing communications path that we have between Outlook mobile devices and the Exchange Online service in order to provide that same functionality that you would get with the mobile client working against an Exchange Online tenant. So with that, you get things that we don't make available on premises. So things like focused inbox, where we're using some intelligence about how users interact with their mail in order to provide a very quick at-a-glance view of the things that matter to them in that focused inbox and allow them to kind of flip over to the other messages in their mailbox when they have the time to go through those as opposed to always having to spend time on managing their mail. Additionally, it enables some of the other components of Office 365 to work properly for managing these mobile devices. Things like Intune app protection and conditional access support become available because of this communications path using these mailboxes within Exchange Online as an intermediary to access the data in the on-premises deployment. And last but not least, one additional announcement. We do have one more release, at least, of Exchange Server 2019, the on-premises product coming. And we plan to make the preview available for this sometime in the middle of calendar year 2018, with a release in the second half of 2018. We'll be providing more details on what specifically we'll be providing in this release as we get closer to that preview becoming available. But if you are interested in getting early access, you can certainly learn more about the Exchange Technology Adoption Program at the link on screen, aka.ms/EX2019 TAP. So with that, I hope this has provided some interesting and useful information about how we manage and operate Exchange Online behind the scenes. And I hope you have a great experience with the product, given all of these investments that we're making.